Hi, today we are going to discuss low-level design of a parking lot, and this is the most common low-level design question. We are going to go through the problem statement, then we will break the problem in multiple classes, and then we are going to code our solution in Java. And finally, we are going to test our code on CodeZym. You do not need to add any main method or write any testing code yourself. CodeZym's testing engine will take care of it. So let's start with the problem statement. This is question number 1 on CodeZym. We have a parking lot with multiple floors, and on each floor there are parking spots arranged in rows and columns. Each floor will have the same number of rows and each row will have same number of columns. Also, as of now, you can park only two-wheeler or four-wheeler vehicles. Now let's discuss the methods that we need to implement. Init is the first method and it is used for initializing the system state. It has two arguments. You should use helper.print or helper.println for printing logs, and this parking array represents all the parking spots that are there in the parking lot. For example, parking 407 means the parking spot on floor 4, row 0 and column 7. And not to mention that all of these indexes are 0 based. Each item in the parking array is either active or inactive, and you cannot park your vehicle in inactive spots. For example, 41 is an active four-wheeler parking spot and 21 is an active two-wheeler parking spot. The 40 and 20, these strings represent inactive spots and you cannot park there. The two main functionalities of a parking lot are park and remove vehicle or unpark vehicle. So what the park method does is it finds an active and empty parking spot based on the vehicle type, and then it assigns that parking spot to the vehicle and maps vehicle number and ticket ID to the assigned spot ID. For example, let's suppose we chose the spot at 0th floor, 8th row and 15th column to park our vehicle. So its spot ID will be 0, 8 and 15, and then it returns a parking result object with 4 fields, namely status, vehicle number and ticket ID. Vehicle number and ticket ID are from the question. The next method that we need to implement is remove vehicle, and this method unparks the vehicle from the parking spot, and exactly one of spot ID or vehicle number or ticket ID will be non-blank. The next method that we need to implement is search vehicle, which is used to find an already parked vehicle, and exactly one of spot ID or vehicle number or ticket ID will be non-blank, and this method also returns the same parking result object with the 4 fields. The last method that we need to implement is get free spots count. This method is used to display the number of free spots of each vehicle type on each floor. That is how many two-wheelers are there and how many four-wheelers are there on a given floor. Now let's see an example of a sample parking lot which is actually represented by the parking array. So this parking lot had got only one floor, and then it had got 4 rows on that floor and 4 columns in each row. And total 7 active two-wheeler parking spots are there. 1, 2, 3, 4, 5, 6 and 7. Also there are 6 active four-wheeler vehicle parking spots there. 1, 2, 3, 4, 5, 6. So this array gives you an idea of how the parking lot is represented or how this parking array actually looks like. Let's start solving the problem now. This is question number 1 on CodeZym. First of all, we have to copy this default code from the CodeZym editor, and this default code contains the class solution. We have to save this code as solution.java in our laptop or desktop so that we can start coding in our local IDE like IntelliJ, Eclipse, Visual Studio Code or anything else that we are using. Also watch this YouTube video getting started with CodeZym. This will clear all your doubts. Here is a list of all the 5 methods that we need to implement all at once: init, park, remove vehicle, search vehicle and get free spots count. Let's start by breaking our solution in multiple classes. Class ParkingFLoor will have the logic to park, unpark and count free spots for each vehicle type, and it is going to be used directly by the class solution. The class ParkingFLoor will also have the parking spot objects arranged in rows and columns. And class SearchManager is going to have the methods to index and search the parking details. of the already parked vehicles, and class parking result is given in the question itself. It is sort of used to pass data. Let's start with the code of class parking result. This class is mentioned in the question itself and it is returned by the methods park and search vehicle. It is used for passing data as we can see, and there are 4 main fields. The first one is status. If the status value is 200 or 201, then it means success, and if the status value is 400 or 404, then it means failure. The other 3 fields are spot ID, vehicle number and ticket ID. Next we have the class ParkingSpot. ParkingSpot is where vehicle is going to be parked. So each parking spot has its own spot ID and vehicle type. Vehicle type is either 2-wheeler or 4-wheeler, and spot ID is a combination of floor, row and column that we just saw. If a vehicle is parked in this parking spot, then each parked will be true, else it will be false. Next is class ParkingFLoor. This class manages all the parking spots arranged in row and columns using a 2-dimensional array. And it has the logic for park vehicle and remove vehicle or unpark vehicle. Also, it has got the method to count the number of free spots for either 2-wheelers or 4-wheelers. It actually maintains the count of free spots counts for the vehicle types in the map, which is also called free spots count. We will go through the code in each and every method in a top-down manner when we are discussing the code in class solution. Finally, we have the class SearchManager. It had methods to index and search vehicle, and it basically uses a ConcurrentHashMap to store all the information. ConcurrentHashMap is nothing but an efficient and thread-safe version of a regular hash map. Next, let's go through the methods in class solution. It keeps all the ParkingFLoor objects in an array. It also keeps an instance of SearchManager object, and then helper is there, which is used for logging. Do not use system.out.println for logs, else your logs will not be visible. The init method initializes all the instance variable, and it also initializes all the ParkingFLoor objects in this floors array. Let's see how a ParkingFLoor is initialized. Basically, it has 2 data structures: the free spots count, which keeps the count of free spots for each vehicle type, that is both 2-wheelers and 4-wheelers, and then it has got the parking spots arranged in rows and columns. So what it receives is a string ParkingFLoor, all the rows and columns. So what it does is, first it initializes the free spots count map, and each is initialized with an atomic integer 0, that is 0 for each vehicle type, both 2 and 4-wheeler vehicles. Then it goes through all the rows and all the columns, and if that particular string represents an active parking spot, that is it ends with 1, then it finds out or extracts the vehicle type from it, and then it initializes the parking spot variable by getting a spot ID using the floor, row and column and the vehicle type, and it increments the free spots count for that given vehicle type. And for example of a spot ID 08 floor, which is like this spot is on floor 0, row 8 and column 4. The second method in class solution is park. It basically goes through all the floors one by one, and if it is able to park on any floor, then it indexes the result and returns it. If it is not able to find any spot, then it simply returns a parking result with 404 status. The actual logic to park a vehicle resides in the park method of the ParkingFLoor. So let's see how that works. What it does is go through all the rows and columns, that is all the parking spots, and then it tries to find a parking spot which is active, where a vehicle is not parked and it has got the same vehicle type as the vehicle type we are looking for. If it is able to find one, then it reserves a spot for that given vehicle. Then it parks the vehicle in that spot and then returns a success parking result using the spot ID, vehicle number and ticket ID, else it returns a 404 that no particular spot is found for this vehicle type. Also, this method is marked as synchronized so that it can be thread safe. When a vehicle is successfully parked on a floor, then what the park method in class solution does is it calls the SearchManager object to index that particular result so that later we can search using spot ID, vehicle number or ticket ID. Indexing simply means adding an entry for this parking result in this cache, which is a ConcurrentHashMap, and what we do is we add an entry against the spot ID, vehicle number and ticket ID for this result. So later we can search this parking result object using either of these parameters. After park, the next method that we have to implement is remove vehicle, and exactly one of a spot ID, vehicle number or ticket ID will be non-blank. So what this method does is it first searches the vehicle using the three parameters. If a search is found, then it extracts floor, row and column from it, and then it calls the corresponding floor object to remove the vehicle at that given row and column. The remove vehicle method in class ParkingFLoor checks that the row and column are both valid and that there is indeed a vehicle parked in that parking spot. Then what it does is it removes the vehicle using ParkingSpot's method remove vehicle. Finally, it increases the free spots count for that given vehicle type. The fourth method in class solution that we need to implement is search vehicle. This method was also used by the remove vehicle method that we just saw. The actual logic resides inside the search vehicle method of SearchManager class, which is called by this search vehicle method. The search vehicle method inside the SearchManager class checks if there is an entry against either of the spot ID, vehicle number or ticket ID. If there is an entry, then it returns the corresponding parking result object, else it returns a parking result object with 404 status. The fifth and final method that we need to implement in class solution is get free spots count. Now, if you remember, the class ParkingFLoor actually manages the free spots count data. So what this code does is it simply validates the floor, then it takes the corresponding floor object and calls the get free spots count method for the given vehicle type. The get free spots count method in the class ParkingFLoor fetches the number of free spots for that given vehicle type, either two-wheeler or four-wheeler, from this map, which is called free spots count, and then simply returns it. This was all, and our solution is complete now. Let's copy it and paste it into the CodeZym editor for testing. Also, when you paste your completed solution back to the CodeZym editor, then you should comment the helper code at the bottom, else it will give compiler error. That is duplicates class and interface definition. Remember, this is question number 1 on CodeZym. Now that we have completed our solution and also commented the helper code at the bottom, I mean this one. So let's run the sample test first and see if our code passes them. Right now it is compiling. Now it has compiled and 2 sample tests have passed already. Let's run all tests. So it may take some time. The number of test cases will keep changing as more and more test cases keep passing. All of our test cases have passed now and it took 70 seconds. So we are confident that our solution is indeed correct. Seeing your code run and pass all the test cases gives you the confidence that if you get this or similar question in an interview, then you will be able to do well there also. And I will put all this code in a blog and add the blog's link to description and pinned comment. I wish you the best of luck for your interview preparation and wish you get the job and the salary you are looking for. Thanks for watching and keep trying other questions from CodeZym and keep improving. Bye.